Good day, my statistics students. We are now going to discuss about understanding the z-scores. The areas under the normal curve are given in terms of z-values or scores. The z-score, z is equal to x minus mu over sigma. This is the z-score for the population data. And z is equal to x minus x bar over s. This is the z-score for the sample data. X is the given measurement, mu is the population mean, sigma is the population standard deviation, x bar is the sample mean, and s is the sample standard deviation. What is the importance of z-scores? Row scores may be composed of large values, but large values cannot be accommodated at the baseline of the normal curve. So, they have to be transformed into scores for convenience without sacrificing meanings associated with the row scores. The graph of the random variables locates the x-scores on the x-axis. In mathematics, these locations are called zeros. We connect this concept to the normal curve concept and call our standard deviations z for zero scores. For any population, the mean and the standard deviation are fixed. Thus, the z formula matches the z values 1 to 1 with the x values or the row scores. For every x value, there corresponds z value, and for each z value, there is exactly one x value. The z values are matched with specific areas under the normal curve in a normal distribution table. If we wish to find the percentage associated with x, we must find its matched z value using the z formula. Z value leads to the area under the curve in the normal curve table, which is the probability, and that probability gives the desired percentage for x. Now here are the examples. Reading scores. Given the mean mu is equal to 50 and the standard deviation sigma is equal to 4 of a population of reading scores, find the z-score that corresponds to the score x is equal to 58. So the formula is z is equal to x minus mu over the sigma. So that is 58 minus 50 over 4. So z is equal to 8 over 4. So z is equal to 2. This conversion from row score to z-score is shown graphically below. So take note that the mean is 50, so it is positioned on the 0. Then subtract 50 to 4 to the left. So that would be 50 minus 4, so that is 46. Then 46 minus 4, that would be 42. 42 minus 4, that would be 38. Then to the right, so you add 4 to 50. So 50 plus 4, that is 54. 54 plus 4, that is 58. 58 plus 4 is 62. Take a look at this. So the z-score that corresponds to x is equal to 58, that is 2. Next example. Score in PE. Locate the z-value that corresponds to PE score of 39 given that the mu or the mean is equal to 45 and the sigma or the standard deviation is 6. So the formula is z is equal to x minus mu over the sigma, or x minus the mean over the standard deviation. So z is equal to 39 minus 45 over 6. Z is equal to negative 6 over 6. So z is equal to negative 1. So the z-score that corresponds to PE score of 39 is z is equal to negative 1. This conversion from row score to z-score is shown graphically below. So this is now the normal distribution. So under it is from on the 0, that is 45. That is because that is the mean. To the left, you're going to subtract it with the standard deviation, which is 6. So 45 minus 6, that is 39. 39 minus 6, that is 33. 33 minus 6, that is 27. Next, we will proceed to the right. So you will add 45 by 6. So 45 plus 6 is 51. 51 plus 6, that is 57. 57 plus 6, that is 63. So the z-score that corresponds to the score of 39 is negative 1. Scores in a science test. Given x is equal to 20, x bar is equal to 26, and s is equal to 4. Compute the corresponding z-score. So the formula for z-score is z is equal to x minus x bar over s. So z is equal to 20 minus 26 over 4. So z is equal to negative 6 over 4. So dividing it, so z is equal to negative 1.5. This conversion from row score to z-score is shown graphically below. So 26, that is the mean score. So as you go to the left, you subtract 4. So 26 minus 4, that is 22. 22 minus 4 is 18. 18 minus 4 is 14. Then as you go to the right, you add 4 to 26. So 26 plus 4, that is 30. 30 plus 4, 34. 34 plus 4 is 38. Then we shall locate the z-score, which is negative 1.5. So 20 is located also here. Evie Angel conducted a survey about determining the current level of students' learning on basic calculus. After checking the questionnaires, she found out that a student attained 60 correct answers. What is the corresponding z-value of the student's score if the sample mean of the test scores was 42 and the standard deviation is 7? So given x is equal to 60, mu or the mean is 42, and the sigma or standard deviation is 7. So the formula for the z-score is x minus mu over the standard deviation or the sigma. So that is 60 minus 42 over 7. That is 18 over 7. So z is equal to 2.57. This conversion from row score to z-score is shown graphically below. So 42, that is the mean score. That is the center or the central part. So you subtract it by 7 as you go to the left. So 42 minus 7, that is 35. 35 minus 7, that is 28. 28 minus 7, that is 21. Then as you go to the right, you add it by 7. 42 plus 7, that is 49. 49 plus 7, that is 56. 56 plus 7, that is 63. Then you locate 2.57 on the normal distribution. So that is there. Then 60 is also there, that part. In the math test, Dan Vincent got 23. In this test, 35 is the average score and the standard deviation is 5.5. What is the corresponding z-value of Dan's score? So given is x is equal to 23, the mu or mean is 35, and sigma or the standard deviation is 5.5. So z is equal to x minus mu over the standard deviation or the sigma. So z is equal to 23 minus 35 over 5.5. So z is equal to negative 12 over 5.5. So using your calculator, z is equal to negative 2.18. This conversion from row score to z-score is shown graphically below. So 35 is the center. So you subtract 5.5 as you go to the left. So 35 minus 5.5, that is 29.5. 29.5 minus 5.5, you will get 24. 24 minus 5.5, you will get 18.5. Then as you go to the right, you add 5.5. So 35 plus 5.5, you will get 40.5. 40.5 plus 5.5, you will get 46. 46 plus 5.5, you will get 51.5. Then we will locate negative 2.18. So we will locate negative 2.18. So it is here. And also 23 is located there also. Now here are the references by Rene R. Belicina, Elisa S. Bacay, and Efren B. Mateo, 2016, Statistics and Probability, Quezon City Rex Bookstore. Also, Statistics and Probability Quarter 3 of Department of Education. Now here are the photo references. Thank you very much for watching and listening. Subscribe for more content on Analyze Math.